All right, class, here we're looking at the transformation reference sheet that I gave you all in class. If you weren't in class today, it definitely is available in the module. So check out the module because it's there. Actually, pretty sure I'm adding this video to where it's located. So I'm hoping that the sheet helps as a quick reference to kind of remembering the different transformations. So let's take a look at the translations, or what we call a shift here. So in this particular case, we are looking at a downward shift. So that means that we're going from that parent function and we're turning into this second function here. And this is what we would take that parent function. We're going to call that parent function f of x. And then we're going to do f of x minus k. So we're basically subtracting that k value from there. Okay. Now, if I wanted to take the original function and I wanted to shift it upward, then we're turning into this function right here. And so that's going to be our original function f of x plus k. Okay. Now, the next one, we're looking at translations from the left to the right. And this is where I was telling you, when you look at the function f of x, this is where it's going to be inside. So a left translation is going to be f of x plus k, sorry. And for those of you who were in class, this is where I believe it was Isabella that was saying, like, oh, think of the opposite. So that's fine if you want to think about it in terms of the opposite. What I would like you to also just consider is thinking about setting that inside where that x is and setting it equal to 0. And we'll look at an example. So here is this left translation. So this is, sorry. This is the left translation. Okay, so now when we want to shift to the right, that's this graph right here. So that's going to be f of x minus h. Now when we're looking at this side, so this is talking about a reflection on the x-axis. So that means we're reflecting about this axis, right? So just think of it kind of rotating or folding your paper along this dotted line here. So if you fold your paper along the dotted line, we get the new dotted graph here. And so that's going to be the same as saying f of, so the negative f of x. So we're applying the negation in front of the parent function. Okay. Now, a reflection about the y-axis, that's now going around this axis. And again, we are cutting this down the middle. We're reflecting it. That's going to look like f of negative x. So we're applying the negative into the inside of the function. So it's being attached to the x value, not the outer part of the function. Okay. Let's look at compressions. This is where I was talking about this a little bit in class today. So in terms of compressions, right, we have a times f of x if our a is a fraction. So we're looking specifically at the absolute value of a is between 0 and 1. And so in that particular case, it's a compression. So think of a weight coming on your function. And so that really creates this wider parabola. So basically, this is equivalent to a fraction, right? Now, if we begin to look at this and we're stretching it, so think of grabbing the function and pulling it. So then this is if the absolute value of a is greater than 1. And that's going to be this graph right here. So notice how it gets thinner than that parent function. Okay. Now this is in terms of vertical dilation. So now we're looking at horizontal dilations. So horizontal dilations take place within the function again. So this is going to be, for instance, f of b of x. And this is if b, the absolute value of b is greater than 1. Okay. Actually, I forgot to mention over here. So coming back over here, this is saying the function will compress or stretch vertically by a factor of a. So a is however it's being compressed or stretched. So we call it a factor of a. So here our compression, whoops, I forgot this bracket. The compression is going to be here. Okay. And so now the stretch is going to be this function right here. So notice how it's being stretched. And so again, this is f of b of x. And this is if 0 is less than b, which is less than 1. So again, notice this is where our fraction is. So what I want you to notice is how these are flipped between the horizontal and the vertical dilation. And so this is going to be a stretch of a factor of 1 over b. Now, in order to get credit for this assignment, you have to complete about 80% of it. And so there are some that are removed just because we're not going to talk about those particular functions. But I do want you to consider this. So start off by making sure that you identify the parent function here. So I at least want to see that. So in terms of your parent function here, I hope everybody agrees that this is going to be x cubed, right? And so what we're going to do next is then talk about the transformations. So in terms of the transformations, it's going to be shift down 4 units. Okay, and that's because of this -4. So test out the rest of these as you go through this, and this should give you like some more additional practice associated to the transformations. When we come over here, you know, we talked a lot about this function today in class. This is our absolute value function. This is notation, so it's going to look like this. This is the parent function. So now we're trying to translate it 4 units to the right. What is that going to look like in terms of the in terms of the equation? Now we're going to reflect it, right? And then we're going to translate 5 units up. What is that going to look like? So you're going to kind of write that down. So if I'm translating 4 units down, sorry, 4 units to the right, that's going to look like, remember, because I'm going to the right, I really want to be 1, 4. I want it to go over here. So that means I need to plug in, be able to grab a +4. So this is going to be -4. Because if I plug in +4, 4 minus 4, that's going to give me 0, which is what I want. So this is going to be that translation 4 units to the right. And now, how does that going to look like reflected about the x-axis and translated 5 units up? So now come back over here and think about, all right, reflection about the x-axis, right? That's this one right here. How is that going to affect the graph? All right, good luck with this. Let me know if you have more questions.